Hello everyone and welcome back. I'm Mr. Cobalt, and in this video I'm going to go over a couple of problems where you're asked to give the electron configuration of various elements. And so what I have here is the chart that you can use if you can memorize this. It's pretty easy to set up. Again, you're just setting up in rows the different sublevels of each energy level. And so you have 1s, you have 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and so on. And so, and I have some extra ones here that the book doesn't have, and that just follows what I had said before, is the energy level will tell you the number of sublevels that you have. So if you're at energy level 1, you only have one sublevel, so 1s. If you're at energy level 2, you have the two sublevels, 2s, 2p, and so on. So if you're at 5, energy level number 5, then theoretically you should have 5 sublevels. We usually only write up to F, and that's mainly because the periodic table only goes up to F, and I'll cover that in another video. But you should have 5 if we're following the pattern. So I put 5G for the next one, and then here we have 6G and 6H because we should have 6 sublevels and so on. But I stopped after 7 because I think you get the point. So, and then you have the arrows going diagonally, and so the arrows going diagonally through the different sublevels gives you the order of the sublevels. Okay, so, or you could use the orbital diagram here. So I'll try to use both. Okay, let's try magnesium. So you need to know the number of magnesium, number of electrons in magnesium. All of these are neutral atoms, so the number of electrons is equal to the number of protons. So you just look up the atomic number for magnesium, which is 12. So magnesium has 12 electrons. The neutral atom has 12 electrons. So I am going to add electrons, right? So I add 12 electrons. So I'm going to add 2 here, spin up, spin down, 2 to the next one, spin up, spin down, and then I'm going to add more to this. So I have 12 total, so I should have plenty. So I have spin up, I'm following Hund's rule, spin up. 1 is being added to each orbital first, all the same spin, and now I'm going to pair them up, spin down, spin down, spin down. So now I have 10 electrons, I have 2 more, so I'm going to put spin up and spin down in the next lowest energy level, which is S3. And then I just write in order of energy. So the electron configuration is going to be 1s2 followed by 2s, and I have 2 electrons in there, and then followed by the 2p, I have 6 electrons in there, and then followed by the 3s, and I have 2 electrons in there. So this is the electron configuration for magnesium. I could have used this as well, right? So I start with this arrow, I go down, it goes through the 1s first, so I fill that in with 2 electrons, 1s. And I go through the next arrow, which is 2s, so I put in 2s with 2 electrons. And then I go through here, I go through 2p first, so 2p comes first, I write 2p and I put 6 there, and then the 3s, and I write that. And then notice that the total of the superscripts should add to the total number of electrons that you have. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. So that is a good way to verify that you've got the right electron configuration. Okay, so what about phosphorus? How many electrons or protons does phosphorus has? Phosphorus has 15 protons and 15 electrons. So instead of 12, we're going to have 15. So we would fill this in again, right? And then we would just add 3 more electrons. But let's do this way for this one. So according to this, I'm going to do the 1s first, so it's 1s. I'm going to put 2 because that's the maximum number of electrons that can fit into this subshell because there's only one orbital. Next is the 2s. So again, 2s and then 2. So I have 4 there. That means I have 11 more to go. So I'm going to go through the 2p. So I'm going to third arrow, 2p, and then 3s. So I have the 2p, and that's going to be a total of 6. I have 10. So that means I have 5 more electrons to do. And then I'm going to do the 3s. So I do the 3s. 2 electrons are going to go in there. So that's 12. I have 3 more electrons. So I'm going to go from the 3s, and then I'm at the end of the arrow, so I go up here, and it's going to be the 3p. So I'm going to go to the 3p, and I have 3 electrons left, so those 3 electrons can go in the p, because the maximum number of electrons that can go into the p sublevel or subshell is 6. So this is the electron configuration for phosphorus. So you could use this to get the electron configuration, and then just make sure that the total of the subscripts or superscripts add up to the total electrons in your element. Okay, what about bromine, right? For phosphorus, I could have just added 3 more, right? So I have 3 more electrons, so then it would look like this. So spin up, spin up, spin up. Right, so that would be the orbital diagram for phosphorus. Oh yeah, what about bromine? So we look up bromine. How many electrons does bromine have? Bromine has 35 electrons. So 35 electrons. So we're going to have to go through this until we use up all 35 electrons. Or we go through this until we use up all 35 electrons. So let's go ahead and use this. So we have 15, so we have 20 more electrons to put in. So that means we're going to pair up the electrons here, right? So that's 18, right? And then we have add electrons, 2 electrons here. That's 20. And then next, 4s, next is the 3d. So we're going to put electrons in here, 1, all spin up, same spin, 1 in each orbital. Okay, and then we got plenty left, so we're going to pair them up. So we're following Hund's rule again. So spin down, spin down. So I have 10 electrons total in there. So that's going to be 30. So this was 20 plus 10 is 30. I have 5 more electrons. So the next one is the 4p. So I have 3d and then 4p. I have 5 electrons left over. So I do spin up 1, spin up 2, spin up 3. And now I can pair them up. Spin down, that's 5. So that would be the orbital diagram for bromine, and then I just write down in order the sublevels and their number of electrons. I could also go through this way as well. So if I build this up, it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, and then we have 4s2, 3d10. So I have my 3d10, and then followed by 4p5. And then if we add these up, so 2 and 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, plus 5 is 35. So that is the electron configuration for bromine. Okay, are you with me so far? Okay, let's do aluminum. So aluminum has 13 electrons. So 13 electrons. So if we follow this, we could have followed this way through here. It would have given us the same one. So 13 electrons. So we're going to go through 13. We're going to go through this until we use up 13. So we're going to start with the 1s. So it has a maximum of 2 electrons, so we put a 2. Next is the 2s. So we're going to put in 2 electrons there. So next is the 2p. So we're going to put 2p, and we're going to have 6 electrons there. 2 and 2 and 6 is 10. So we have 3 more electrons. So after the 2p, we go to the 3s. 3s, and we put 2 electrons in there. That's 12. I have 1 more electron. Where is that going to go? So I have 3s. I go up here, and it goes to 3p. So 1 electron in the 3p. So that would be the electron configuration for aluminum. Okay, let's keep going. So we have 4 more. What about chlorine? We look at chlorine, and chlorine has 17 electrons. So if we erase, let's erase here, so we can use our orbital diagram again, right? So here we're going to erase that, erase this. Okay, so we have 17 electrons, so 17, so we're going to build it up. So spin up, spin down, that's 2. Spin up, spin down, that's 2. And then we're going to do spin up, spin up, spin up, so that's going to be 3. And then we're going to pair them up, spin down, spin down, spin down, following Hund's rule. So now we have 10. We have 7 more to go. So we're going to go to the next one, spin up, spin down. That's 12. 5 more to go. And then we're going to do spin up 1, spin up 2, spin up 3, spin up or spin down, pairing up, spin down, pairing up, that's 5. So that's 17 electrons. So then we're going to write our electron configuration. So it's going to be 1s2, 2s2, 2p, what is it, 2s2, 2p6, 3s2, and then 3p5. And so that's the electron configuration for chlorine. What about silicon? Silicon has 14 electrons. So we're going to follow the same pattern. So it's going to be 1s2, right? Now we're going to stop at 14. 1s2, 2s2, 2p6. So now we have our 10. And then we got 3s2. That's going to be 12. And then we have the 3p2 for 14. So silicon again has 14 electrons. So that's going to be our electron configuration. So we count up to 14, or we can go through this one and then add up the total number of electrons and we stop when we use 14. Okay, what about strontium? Strontium is, let's see, where are you? .38 electrons. So we have 38 electrons. So we could go through this until we hit 38, or we could go through this until we hit 38. So it's either way is good. So we can go through this way. So 1s, 1s2. And we keep going. I'll continue this in the next video since we're not going to have time to finish. So I'll see you in the next video. Thanks for joining me. I'll see you next time.